Alright, so this is October 22, M1, question number 4. This is a lift math. Okay. Two children, Alan and Bhavana, are standing on the horizontal floor of a lift as shown in figure 3. The lift has mass 250 kg. The lift itself, we draw the lift, has a mass of 250 kg, so that's 250 g force downwards. The lift is raised vertically upwards with constant acceleration by a vertical cable which is attached to the top of the lift. You have the cable over here. The cable is modeled as doesn't matter. While the lift is accelerating upwards, the tension in the cable is 3616. 3616. Again, only the lift experiences the tension force because it is connected to the cable. Air resistance is modeled as being negligible, and Alan and Bhavana are modeled as particles, of course. Okay. As the lift accelerates upwards, the force of the lift exerts a force of magnitude 565 newtons on Alan and a force of 226 on Bhavana. Alright, if I were to draw Alan, let's say this is Alan. So he has what? He has 565 newtons from the lift, so that's 565 newtons. Why am I drawing this upwards? It says the floor of the lift exerts a force of 565 on Alan and as such on Bhavana, right? So why is it going up? It's the lift, right? The lift is below them. The lift is below them. So in order for the lift to put a force on them, it's gonna be up, right? So that's why it's up. You can say it's the normal reaction force provided by the lift to Alan and Bhavana, alright? And then Alan has his own mg, okay? And then Bhavana has her own, what do you call it? Normal reaction force from the lift, which is 226 newtons, and then she has her own mg, right? Okay. The lift is giving them 565 and 226 newtons respectively. So I wrote Bhavan, this Bhavana. Okay. So if the lift is giving them 565 newtons and 226 newtons respectively, they must also provide those forces back, 565 and 226. It must be balanced, otherwise they would not be on the floor of the lift, they would be flying away. Alright? It must be balanced. So if the lift is giving them the normal reaction force of 565 and 226, they will be providing those forces respectively back to the lift, alright? We're providing them back to the lift, alright? So the 565 and 226 will go on both diagrams, okay? Normal reaction forces go on both objects, alright? By considering forces on the lift only, find the acceleration of the lift, alright? By considering forces on the lift only, I have diagrams drawn that consider forces on the lift only, right? And then I have diagrams for Bhavana and Alan, whatever. Okay. So it's going up, right? It's going up. Do I have acceleration? Okay, I need to find acceleration. Never mind. They asked me to find acceleration. Alright. So going up, the F equals to ma equation is going to look like this. So you have 3616, and remember, Jatin, tension always acts away from the object you're considering it to be. Alright. So tension is going to act away from the lift. 3616 minus 250g minus 565 minus 226 equals to ma, and they've told me that the lift has mass 250g, so 250 kg, so that's going to be 250 into acceleration. If you solve this, you will get acceleration to be, let's just give it to you from the marks, so it's going to be 1.5 meter per second square. Alright, that's the, okay. So remember, normal reaction forces are exchanged between each other. Otherwise, the objects wouldn't stay on top of each other. Newton's third law will not be obeyed. In order for two objects to stay on top of each other, normal reaction forces are exchanged. That's why normal reaction forces go on both diagrams. Alright. So since I'm already only considering forces for the lift itself, I will not be considering Alan or Bhavana's mass. Okay. Their masses will not be here. Okay. Alright. Find the mass of Alan, okay. for Alan, let me just erase Bhavan, I do not need her. Okay, so Alan, let me come up with the F equals to ma equation for Alan. It's part B. Okay, the F equals to ma equation for Alan is gonna be, you have 565, that's the normal reaction force from the lift, and then you have minus mg equals to ma. I know the acceleration for the entire system will be the same. Okay, so if you solve this equation, m is the only unknown, what do you call it, variable over here. If you solve the equation, you will get 50 kg. Alright, that's it. Let me know if you have any issues.